Hello and welcome to the video version of Technology and Space, where we talk about the science, technology, history, and business of space exploration and commercialization. I'm Chris Alvarez, and thank you for watching. I'm speaking with Martin Cooper, the father of the cell phone, and also author of Cutting the Cord, The Cell Phone Has Transformed Humanity, published January 5th, 2021 by Rosetta Books. Thank you for speaking with me.
My great pleasure, Chris.
So, I'm sure you're ready for all the history questions I'll be asking you. I want to reach back to you started out, I guess your first engineering job was with the Navy. Is that correct?
Well, you could call it a job. The Navy was nice enough to put me through college,
Okay.
and in order to get even with them, I had to serve in the Navy for 3.5 years.
Okay.
And it turns out that was a great experience. The Navy made a man out of me and taught me a great deal. So I'm very grateful to the U.S. Navy.
So were you sent out to Korea, or were you stationed somewhere else during the war?
Yeah, no, I was started out on a destroyer.
Mm-hmm.
I did participate in the Korean action,
Mm-hmm.
and then I went to submarine school and I became a submarine officer.
Okay. So the Navy did use your electrical engineering skills then?
Yes, I was. Every officer of the Navy has multiple roles, and I was always an engineering officer
Mm-hmm.
aside from the other roles that I had. Yes.
Okay. So what did you learn in the Navy that eventually contributed to the great success you've had within your field? Um, with the cell phone and also with the companies you've started and that sort of thing.
Well, the most important thing is that an individual can accomplish very little in today's society,
Hmm.
especially an engineer. You have to deal with other people and building trust in people, inspiring people. Um, uh, those kind of things are just crucial. You can't do anything all by yourself.
Hmm.
And everything you do in the Navy is based upon teamwork. You still need leadership.
Hmm.
And they emphasize a lot of that as well in the Navy environment.
Hmm. So when you did get out of the Navy, what was your so I guess 1973 is the big year when you came out with a cell phone, you and your team. In the intervening years, can you talk about sort of how you developed your skills, your approach to innovation and technology?
Well, I started to work for a company called Teletype.
Hmm.
You're too young to know what a teletype machine is, I think, Chris. Uh,
Yeah,
but
a little bit, yeah.
Teletype was at that time a part of the of Western Electric, part of the Bell system,
Hmm.
and I lasted there for a year. And it turns out these people didn't really understand that the world was becoming electronic, not mechanical. Teletype machine is essentially a printer. It's all mechanical. It has the only electrical thing in a teletype machine is a motor that runs things. So I
Hmm.
lasted a year at Teletype, went to Motorola,
Hmm.
and it was the luckiest thing that ever happened to me, Chris, because Motorola allowed me to participate in the role of an engineer and ultimately a manager, but they also let me think on my own, uh, evolve and innovate products on my own, and it was just a great experience.
So actually, that makes me wonder. Just stepping back, you said you went to you were in submarines in the Navy. Did you do communications technology at all for submarines or
Well, I
something
was
else?
a submarine officer. Submarine officer got to be able to do everything,
Oh,
and so you could be an engineering officer, but when there's an emergency, you have to take on any role,
mhm.
including firing a torpedo, as an example.
Okay.
So you in the position that I had, there were no specialists. You had to be a generalist.
Okay. Okay. Okay, so you were part of the leadership team then? Because I thought it was okay. So did you have engineering officers under you then?
I'm sorry, repeat the question, please.
Did you have engineering officers working under you then in the
Oh,
submarine?
no, I had enlisted men
Mhm.
who were professionals in their fields,
Mhm.
and they did the real work.
Yeah, okay. So, so with Motorola, can you talk about sort of the growth that you experienced there? Like what sort of things did they have you do that helped you advance within the company?
Well, you got to work on engineering
Mhm.
project, and the projects got more and more difficult.
Mhm.
And we had more and more involvement. And you got to the point where you had people working with you.
Mhm.
So Motorola, the biggest thing that I learned at Motorola is the importance of objectivity. It's
Mhm.
results that count. It's not personality. And in fact, you try to subvert your personality and look at your problems and issues objectively.
Mhm.
And so I thought that was wonderful. There were times when I got involved in really intricate projects. I worked for NSA
Mhm.
in Motorola for a period of time. Learned about cryptography, which was really primitive
Mhm.
in those days, uh, and got to the point where I could create my own products,
Mhm.
and that was a thrill, getting to invent things, and then going beyond that, as I mentioned before, working with a team and inspiring the team to do things way beyond any one individual could do
Mhm.
is another thing that Motorola taught me, and that was a great part of that experience.
Now, as computing developed over this period of time, how did that impact the work you did? Did you do any coding or were you all electrical engineering or how did that play out?
Well, interestingly enough, I introduced the first engineering computer into Motorola.
Hmm.
IBM came to us, and they had this really primitive device, primitive by today's standard. You
Mhm.
program this first computer with a plug board.
Uh-huh.
You could imagine that. I don't think anybody modern individual could imagine programming a computer with a plug board.
Mhm.
But I put that computer into my office and worked out some elementary programs. And I knew that I was successful when my guys stole the computer from me so they could solve real problems. And that computer lasted for perhaps a year before we got to the point where you could program computers with uh, first with tape, with
Mhm.
punch cards,
Mhm.
if you could imagine it, and ultimately where you could actually create a program in software.
Mhm. Okay. And how about the development of satellites over this period? Were you doing any work with that?
No, not at all. The only involvement Motorola had in satellites is they actually created the you know the name of it. So
Oh, oh,
I got a mental
yeah,
Iridium.
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 Yeah, yeah. Yeah.
Yeah, Motorola created the Iridium program. In fact, it
Mhm.
was my boss who stimulated this, John Mitchell. The program was successful. The marketplace was not successful, as you know. The thesis of Iridium was that there are many, many places in the world where you could not have wireless communications.
Mhm.
And what the team didn't quite figure out is that most of the world is going to be covered by cellular communications a lot faster than anybody ever anticipated.
Hmm.
So Iridium still exists today, but it probably will not exist for too much longer.
Mhm.
Uh, there was just not a big enough market for what it offered.
Okay. I also want to talk about science versus engineering. How much, scientific research was being done at Motorola, if any, and how much was just application of new ideas that had been discovered?
Well, everything that we did, at least in the communications areas that I was in, and later on I was the vice president of research for the company, but Motorola did applied research.
Mhm.
When there were areas where we needed to evolve things to increase our ability to achieve our business objectives, we would do the research, but it was not fundamental research.
Mhm.
Everything we researched was focused on achieving our objectives.
I'm speaking with Martin Cooper, author of Cutting the Cord. You can find more information about his work at martycooper.com. If you like this episode of Technology in Space so far, please subscribe and hit the like button. If you'd like more books and information on space history or the science, technology, and business of space, check out my YouTube channel, Spacewalks Money Talks, my podcast, Technology in Space, and my website, technologyandspace.com. If you're looking for military history and general history, including true crime, please check out my YouTube channel, War Scholar, my podcast, Military History Inside Out, and my webpage, warscholar.org or militaryhistorypodcast.com. If you're looking for fiction, including sci-fi, horror, fantasy, mysteries, thrillers, film history, gaming, and more, please check out my YouTube channel, Chris Alvarez Full Contact Nerd, my podcast, Full Contact Nerd Interviews, and my webpage, chrisalvarez.com or fullcontactnerd.com. Now back to the video. So were your customers, and I guess it would probably have changed quite a bit over the years, was it mostly government, or were you focused on the commercial market, or how did you balance that out?
I started in the communications division,
Mm-hmm.
and our customers were public safety,
Mm-hmm.
businesses. It turns out that anybody that had resources that were mobile, that were moving around, could only manage those resources if they had radio communications.
Mm-hmm.
And so that's what we did, is we built two-way radios, later on portable two-way radios,
Mm-hmm.
and as data became usable in wireless systems, and we evolved that into what exists today. And Motorola Solutions is still the world's leading producer of public safety communications.
Mm-hmm.
Very, very complex computer-oriented communications. So that's how we started.
Mm-hmm.
Ultimately, I did start a division that did that became the cellular division of Motorola.
Mm-hmm.
And of course, Motorola also had a semiconductor division. They had a government division,
Mm-hmm.
and I did manage the research for that entire organization.
Let me ask you a management question. Because scientists and engineers can kind of be particular sort of individuals, sometimes loners, sometimes wanting to do their own thing. How do you manage, people with this, great intelligence and ability who might not be able to work in a team as well as you would want them to?
Well, that's a hard question. we only have an hour to do this, Kristen. I could spend years talking about. I have a thesis that every person is different from every other person.
Mm-hmm.
Don't you believe that?
I do.
And so you have to deal with people as individuals and as people,
Mm-hmm.
but you also have to be objective. I keep repeating that. You have to eliminate the issues of personality from technical and scientific objectives.
Mm-hmm.
The worst thing an engineer can do is to fall in love with whatever he's working on and forgetting about what's the purpose. What's the purpose of technology? Technology is the application of science to create products and services that make people's lives better.
Mm-hmm.
forget about the people part, and it's not technology, it's curiosity.
Mm-hmm.
So the most important thing in dealing with people is respect, both ways.
Mm-hmm.
Having people like you as a leader is not a bad thing, but that's not your objective. You want people to respect you, and the only way you can do that is for you to respect them and to work together as a team.
Mm-hmm. Have you written any of your ideas about management down either in this book or maybe in others?
I've done a whole bunch of papers in the past.
Mm-hmm.
The most important thing that I've written about, and maybe that'll be my next book,
Yeah,
Chris, if you encourage me enough,
I might.
was the concept of the technology roadmap.
Mm-hmm.
We don't do enough predicting. We
Mm-hmm.
don't do enough predicting using predictive tools rather than just guesswork.
Mm-hmm.
Because I suspect that I think you mentioned you're a science fiction fan, and I am as well.
Mm-hmm.
One of the important things about science fiction is that you would like to think that when you think about the future, that you're embracing science, that you're not just coming up with stuff that's imaginative, that's fantastic.
Right.
So that has been a hallmark of what I've tried to do with regard to the technology roadmap. There are
Mm-hmm.
all kinds of tools that can be used. One of them is the experience curve.
Mm-hmm.
You can pretty much predict what the price of a commodity is going to be
Mm-hmm.
just by knowing what the past history is.
Mm-hmm.
Sounds crazy, but let me tell you, knowing what the price is going to be is crucial in when you're developing a product.
Mm-hmm.
And there are many other tools, and so what we developed at Motorola, and which became a passion for me for a number of years, is
Mm-hmm.
the ability to accumulate all these tools and have the engineers have objectives that are meaningful,
Mm-hmm.
objectives that solve real problems in society,
Mm-hmm.
and that do that in a way that is economic, meaningful, and timely.
Mm-hmm.
Unfortunately, I haven't written a lot of that down, but there has been a great deal of literature on planning and on the technology roadmap. Uh, I, I wish that I had come upon this passion sooner, Chris. Now that you mention it, because there are places, as an example, the FCC deals with, is the Federal Communications Commission,
Mm-hmm.
deals with technology, communications technology, and yet the commission are all lawyers and politicians.
Yeah.
No engineers on the Federal Communications Commission. They should be doing the kind of planning that I'm talking about. They should be trying to figure out what the future technologies are so that they can focus the changes in the way we manage the radio spectrum and the way we manage communications in general on the future instead of just extrapolating the present.
Yeah. Yeah. I was going to ask you later on, I was going to ask you what it was like to advise the FCC, and it sounds like you partly answered that already.
Yeah, well, I'm doing my best, and I serve on the Technology Advisory Council for the FCC.
Mm-hmm.
But the FCC's got a very difficult task.
Mm-hmm.
They are run by Congress.
Mm-hmm.
They have to do what the politicians tell them to do, and that's very difficult for a technology-based organization to do. So I have beliefs that the radio spectrum is not managed in the best possible way,
Mm-hmm.
and I'm doing what little I can to persuade people that they should be improving that.
Would it require a big fix or just slight tweaks here and there to make it better?
Big fix, Chris.
Okay.
So
Okay.
you think about the way we manage spectrum today. I don't know if this is an appropriate subject for your
No,
uh,
please, please.
podcast,
Yeah.
uh, but if there were more wrong ways that manage the radio spectrum, and the FCC hasn't found them yet because we do everything wrong. We assign spectrum in little hunks. We give a radio station or a television station or a cellular carrier a piece of spectrum. And once we do that, we license the spectrum to them, but we allow them to treat the spectrum like they own it. Well, they don't. We own the spectrum. We just license it to people. And they have an obligation to use the spectrum in the public interest and convenience. Well, they don't do that. And the bottom line is that we are horribly inefficient at how we use the radio spectrum today. Ultimately, all communications systems will share the spectrum, and any transaction that occurs, any conversation, the kind of thing that we're doing now, will happen in an optimum way. If it's a wireless conversation, it will use a minimum of a spectrum, a minimum of the area, minimum of the time. And if you do that, if you have everybody using only what they need in the radio spectrum, they use the optimum frequency band, the efficiency of spectrum use will go up. This is going to sound ridiculous to you, by millions of times.
I can see
Not
that.
just adding spectrum, but multiplying it. That's how inefficient we are today at using the radio spectrum. There is a myth that spectrum is like beachfront property. You know, there's only so much of it, and once that's gone, there's no more. Well, that's insane.
Right.
If you think about Marconi 120 years ago was delivering data at the rate of a bit every 6 seconds. Sounds ridiculous, doesn't it? But we are now, I've really worked out this number, we are now 10 trillion times more efficient than Marconi was.
Yeah.
So, and it's the same spectrum.
Yeah.
So it's technology that decides what the capacity of the spectrum is. And what we have to do is require people to use the latest technologies so that we can keep accommodating all the new applications. And we have managed to do that for 120 years. Never been a shortage of spectrum. There's only been this myth the spectrum is scarce. And yet anybody that wanted to do something new, we wanted to do a new cellular concept, sure enough, we could do that. When the satellite people come along, oh yeah, there's lots of spectrum for that. So somehow we have managed to expand the capacity of the spectrum faster than the needs of society.
So how does that work with your law of spectral efficiency, what you just described? Does it take that into account, or would your...
That's only an observation. It's not a law.
Oh, okay. I saw it described as a law.
It is. We call it that, and some people call it Cooper's law.
Yeah.
But it really is an observation that somehow we have doubled the capacity of the spectrum. This is just a measurement every 2.5 years. And we look at the technology available to us that we're not yet using. It's my belief that we can keep doing that for at least another 50 years with technology we know about. And you know that we're going to keep coming up with new things.
Right.
There's no reason to believe that we can't deliver all of the data that people need wirelessly indefinitely.
Let me step back, well, to the cell phone, the development of the first cell phone. What about the system, or the phone and the system? What was the difficulty that made people so skeptical about being able to do this?
Well, you're right about people being skeptical, and the skepticism was not related to the technology. It was people had been trained for their whole life to accept the fact that the telephone wire was the connection. that if you wanted to talk to somebody at a distance, you had to do it with the wire. And the idea that you could do this with wirelessly
Mhm.
was very difficult for some people to accommodate.
Mhm.
Those of us that read Dick Tracy didn't have that problem because Dick Tracy had a wrist phone,
Yeah.
and it's absolutely the truth that we worked very hard to come up with a wrist two-way radio.
Mhm.
And just about when we did succeed that, it was a pretty big risk that it would take to hold that radio at the time. Uh, Dick Tracy came along with a wrist video phone. So he stayed ahead of us and set that wasn't science fiction, that was the comic books,
Right.
uh, but it was visionary.
Mhm. Yeah. Well, since we do mention science fiction, or since you mentioned it, what are some of your favorites? I thought of Asimov's Foundation when you talked about, predictive ability and technology. Um, but what did you like? What sci-fi do you like?
Well, of course, I read all of Asimov. I also read Ray Bradbury. And, you go through the list, and I've done them all.
Mm,
And I've actually forgotten more that,
yeah.
that I've read because I still do. I still read analog.
Mhm.
Do you subscribe to analog science fiction?
I used to. I don't have the time to read it, but yeah, I'm familiar with analog, and I'd like to be able to, but
Oh, is that you're an organized guy? I am not. I am not organized. I'm fortunate enough to be able to do whatever I want to do, and I still keep busy all the time. But every once in a while, I'll pick up a science fiction story and read it.
do you feel like you're still reading sort of visionary stories that can lead the way to new technology within sci-fi?
Anything that stimulates your mind
Mhm.
beyond the everyday thing is useful in that regard.
Mhm.
So I have a belief that well, the thing that thrills me the most is
Mhm.
having a new way of looking at something. To
Yeah.
me, it's thrilling, and most of the time, it turns out there's nothing really new about it. Other people have thought about it if I dig into it,
Yeah.
but at least I know that I thought about that personally,
Mhm.
and that is, if there's a big thing in my life, it is that. It is having the thrill of a new idea. It's getting together with smart people like yourself, uh, and having people ask questions,
Yeah.
and all of a sudden you think of a different way of looking at something, and that creation is the most stimulating thing in my life.
So, so to go back to the cell phone again, the little incident about you calling your rival at AT&T, was that planned or was that a spur of the moment kind of thing?
It really was serendipitous, Chris. I just uh, the important thing that I was thinking about when we were out on the streets of New York,
Mhm.
I mean, with this reporter,
Mhm.
and I deliberately got out on the streets because I wanted him to understand the concept of mobility,
Mm.
that we were creating, that the old phone was a device that connected a place to another place.
Mhm.
We were going to be connecting a person to another person. It
Right.
was a whole different something. So there we were out on the streets. And that's when it occurred to me, you know what? The guy that doesn't believe that is my counterpart at AT&T, Joel Engel. I'm
Mhm.
going to give him a call. And
Uh-huh.
I pull out my address book.
Mhm.
I wanted you to know how primitive we were at the time, and looked up Joel's number and called him.
Mhm.
And miraculously, from a historical point of view, he answered the phone.
Yeah.
Not just I said, Joel, it's Marty Cooper. He says, hi, Marty. I said, I'm calling from a cell phone. He says, really? I said, yeah, but it's a real cell phone. It's a personal, handheld, portable cell phone. Notice I didn't resist rubbing it in. And Joel was non-committal. He was polite.
Yeah.
To this day, Joel does not remember that phone call. I guess I don't blame him, but
Uh-huh.
he doesn't dispute that we did have that conversation.
Maybe he was busy and he just thought you were pranking him or something, and like, yeah, okay.
Well, he still does not believe that the cell phone is a very useful device,
Hmm.
and he doesn't believe that we had any impact on the creation of the cell phone, despite the fact that the system he was working on only expanded the wire line into the car,
Hmm.
which we thought was just inappropriate.
Hmm.
Uh, we believe that that personal communications ought to be everywhere.
Hmm.
That people wanted the freedom to be able to communicate wherever they are and whatever they were doing and whatever the time was. And of course, we turned out to be right. And there are more cell phones
Hmm.
in the world today than there are people.
Yeah.
I guess we must have been right. But I dodged the question you asked, Chris, about were there technical challenges to the cell phone?
Hmm.
And you bet there were. If you could imagine this cell phone, the first one that we did had over 400 channels. We had never built a radio that had more than a dozen channels in it.
Hmm.
So the device that did that, that allowed you to do that, was a synthesizer, and this was an integrated circuit.
Hmm.
It had just been created in our semiconductor laboratories, so we got the first lab units to do that part of it.
Hmm.
The idea of having a transmitter and receiver at a gigahertz, at 1,000 megahertz,
Hmm.
was unique.
Hmm.
It had not been done in a portable before. That was a major challenge. Of course, today, a gigahertz is nothing. We have cell phones that operate at 2.5 gigahertz, and
Hmm.
very likely will go up to 6 gigahertz and more. Uh, Even the antenna was unique. The ability to talk and listen at the same time,
Hmm.
unique. So there were a number of challenges, but fortunately, we had been working on various things in our laboratories. And as you might have figured out, I'm a techie. I love to wander around the labs, find out what people are doing. And
Hmm.
somehow or other, we managed to find in our labs all of the elements of technology, including the system technology,
Uh-huh.
to put this thing together. And we did. And what we created was very different than what our competitor with the Bell system was proposing, because we were operating in 3 dimensions.
Hmm.
The Bell system was talking about being in a car.
Hmm.
Cars were always at ground level.
Ah.
Uh, we had to anticipate the fact that somebody could get in an elevator and go up 100 stories.
Yeah.
And if they keep putting out the same power on floor 100 as they were on the first floor, they would take over an entire city. So we have to include things like power control, and so the team managed to put that together in a little over 3 months. It was just a remarkable achievement, and that's one of the reasons that I wrote "Cutting the Cord,"
Hmm.
is I really wanted the world to know what an achievement uh, uh, my team and Motorola did at that time.
What about the infrastructure on which the signals were carried? Did you have to create something special for that?
You bet. The infrastructure included a switch. Well, we managed to take an existing wireline switch
Hmm.
and convert it, but you also needed a base station.
Hmm.
You needed a way to determine when you wanted to hand off the signal from one station to another.
Hmm.
So we had to do all of that while we did the handheld phone. None of that required extraordinarily new technology. It's the phone
Hmm.
that was really a challenge. And I don't know, is your podcast just audio or is it visual as well?
I'm gonna do a visual version as well. So both.
Well, here it is.
Yeah. Yeah.
This is what the first cell phone looked like.
Hmm.
This thing weighed almost 2.5 pounds,
Hmm.
and a battery life of 25 minutes of talking.
Hmm.
You wouldn't think 25 minutes is very long, but you couldn't hold this thing up for 25 minutes.
Yeah. I'm speaking with Marty Cooper, author of Cutting the Cord. You can find more information about his work at martycooper.com. If you like this episode of Technology in Space so far, please subscribe and hit the like button. If you'd like more books and information on space history or the science, technology, and business of space, check out my YouTube channel, Spacewalks Money Talks, my podcast, Technology in Space, and my website, technologyandspace.com. If you're looking for military history and general history, including true crime, please check out my YouTube channel, War Scholar, my podcast, Military History Inside Out, and my webpage, warscholar.org or militaryhistorypodcast.com. If you're looking for fiction, including sci-fi, horror, fantasy, mysteries, thrillers, film history, gaming, and more, please check out my YouTube channel, Chris Alvarez Full Contact Nerd, my podcast, Full Contact Nerd Interviews, and my webpage, chrisalvarez.com or fullcontactnerd.com. Now back to the video. So when you made that first call, I guess you had to be cognizant of how far you were from the station that you were using, right?
The station was right across the street.
Okay.
So
yeah.
we knew that part of it was going to work.
Yeah.
Having the phone itself work was problematic because we were still fixing stuff in the phone the night before. Remember, this is a one of a kind, and it was done with discrete components, individual parts put together. There are several times more parts in this phone that does only talking and listening than a modern cell phone that has a supercomputer in it, a digital camera. So having all these hand-wired parts in there, the thing that I was worried about most was, is this thing going to keep working for my whole demonstration?
Yeah. So what about when you finally decided to mass produce a model? How about, developing the manufacturing processes for these phones? Was it difficult, for all the little intricate parts?
Well, the first part was creating the technology. The integrated circuits that we used in this phone had just been created. It took years to get to the point where we could do those things duplicated. And 2.5 pounds is just too heavy. So we really, it took 10 years for us to get to the stage where we could build a phone reproducibly, exactly what you just said, and with a performance that was acceptable. And so the first commercial cell phones didn't go into service until 1983. It took a good part of that time for the FCC to decide who was going to be the carrier. We're going to have a monopoly, or would there be competition? Well, you knew which side we were on. So, and then when the FCC started to get ready, we weren't ready. We still hadn't worked out all the manufacturing processes. So it took a good 10 years to get this technology going. But when we did it the right way. We did it with true personal communications.
Now, this question, forgive my ignorance, but so that first phone, how much computing power was in it, or did it use any kind of computing, or how?
The only real computer in there was the synthesizer that I mentioned to you. And I think you know what a synthesizer does. There was a quartz crystal oscillator in there, and somehow or other for every channel that you wanted to be on, you computed what that frequency had to be, and generated it arithmetically. So that's all this computer did, but there was nothing that you would call a computer in that phone. It was everything was, aside from the synthesizer, everything was analog.
And so when people work on this kind of technology for Motorola or another company like it, do you get any sort of benefits from the patent, or is it the company just owns it all, or?
When I joined Motorola, I had to sign a document that turned over any intellectual property that I created while I was at Motorola or for a year after I left, and for that they gave me $1.
Hmm.
and it was the best deal I ever did, Chris. You know, Motorola tolerated me for 29 years and allowed me to exercise my creativity, and I have been everlastingly grateful to that company.
So, so once you did, once the cell phone became sort of a mass market product, what were some of the challenges that existed as far as, at that point, were you just competing with others to make better phones, or what was the barriers you were trying to overcome at that point?
Well, after we ended up creating that first phone, we actually built five different versions of that phone before we had a commercial one.
Hmm.
And then I moved on to other things. I ended up managing all of research and development at Motorola, and other people took on the cellular challenge.
Okay.
But the big challenge, there was just one after another. And after I left Motorola, which I did just about the time when the phones became commercial,
Hmm.
my wife and I started a company that did the billing and management of cellular systems.
Hmm.
And would you believe these new companies that took on the role of providing cellular service never did figure out how to collect the money, how
The
to put out
important
the bills.
That's
And
an
so we
important.
did that for a number of years.
Hmm.
We provided that service. So this business started out in the smallest way and grew to one of the biggest businesses in the world today.
Now, was the ability to figure out how to bill and collect money, was that a technical challenge, or did you just happen to see that problem existed and jumped on it?
Well, it was a business challenge as well because there were things that were happening that just didn't happen elsewhere.
Hmm.
One of the example being a roaming, the ability for a user to go from one city to another.
Hmm.
Nobody thought that was going to be very important either. And of course, people don't even think about it now. But the first phones, you could use it in your city. And if you try to use it in another city, if there wasn't an agreement between those two cities, you couldn't use it.
Huh.
And when you did use it, they collected the data in one city on a roll of tape
Hmm.
and mailed the tape to the other city, if you could imagine that. It, all of that is done instantaneously today
Hmm.
because everything is connected to everything else. And we have roaming not only within the US, but you could roam virtually into any city in the world
Hmm.
and use the same cell phone.
So what would you say is and you did mention a technical map, like how do you think, how do you apply sort of visionary type of thinking? How do you think looking into the future and what you expect to happen? What approach do you take?
Well, the most logical approach is to put yourself into the mind of the user. You know, I'm back to this issue of technology is nothing without people.
Hmm.
And what innovators do is they just constantly look around. My wife is like that, almost to an annoying extent. She will look at anything and say, you know, I can do that better.
Hmm.
And that's what innovators do. They look at any problem and or at any situation and say, I can do that better.
Hmm.
And so the bigger their storehouse of uh, of tools, of technology, of different ways to do it, the more things they have available, and the more able they are to solve these many problems to innovate. That's what innovating is. There
Hmm.
are no 100% original inventions.
Hmm.
I have a belief. It's almost like how the universe was created. That there has never been an invention that wasn't based upon somebody else's
Hmm.
invention or inventions. So the important thing for innovators is to know as much as possible about what is possible and then put those things together in ways that have not been conceived before.
What scientific breakthrough that we're approaching are you most excited about? You know, there's all these things that, you know, we talk about. Um, what inspires you?
Well, uh, I learned, I started a company some years ago in 1992 that introduced smart antennas
Mhm,
into society. And what I learned was that, that the way to approach that problem was to take a group of antenna elements. I'm afraid I'm getting into more detail than I plan to,
no, it's
but
fine.
figure out what is the optimum combination of signals,
Mhm,
go from one point to another to achieve an objective.
mhm,
The objective is to have a good communications path.
yeah,
There were people that were taking multiple antennas and creating beams. Well, a beam is a construct that might or may not be useful. It was not the right approach to the problem. The right approach to the problem is optimizing, setting up rules that optimize the best solution
mhm,
to a set of circumstances. And what I discovered is you can apply this to virtually anything.
mhm,
And it goes back to this thing that we talked about at the beginning, how inefficient we are at using spectrum today, that when we optimize sharing of spectrum, we're going to find that there's huge capacity to to the radio spectrum.
mhm,
And then if you take this uh, concept of optimization and look at politics,
mhm,
you discover why the American system, American approach to democracy, highly flawed, as you well know,
yeah,
is still the best. It's emulated by countries all over the world, and it's still the best way to do it because it is a self-optimized system.
mhm, yeah,
If you have a hierarchical system where the boss says this is the way we're going to do it, you will never achieve optimization.
right.
But if you have a system that keeps correcting itself and sometimes overcorrects,
Mhm,
ultimately it's going to move toward the optimum. And so, one of the things that I advocate at the moment in almost any situation is applying this concept of self optimization. So, I can't design circuits anymore. They when you've got a chip that contains 2 billion transistors, the first product that I created when I came to Motorola, which was a self-contained product, had 39 transistors in it,
yeah,
and it was in a box all by itself, and it performed its function.
mhm,
Well, the difference between 39 transistors and 2 billion puts me out of business, but I can still think at high levels.
yeah. So, I noticed in a 2013 interview, you described the cell phone as being in its infancy, and now in 2021, where would you say the cell phone is?
It's a slightly more grown-up infant. The cell phone is suboptimal
Mhm,
in almost every respect. I happen to have my latest phone here, which is a pretty nice phone. It's an iPhone. It's
mhm,
an 11, not a 12.
mhm,
But if I want to make a phone call, I have to lift the phone up in this awkward position,
yeah,
take this flat piece of plastic and put it against the curved end. And it is not an optimum phone,
right,
nor is it an optimum visual device because I got this little tiny screen that I'm looking at.
mhm,
And it's not optimum for virtually anything that it does. And yet you know that if you focused on each one individually, if you made an optimum phone, you know what it would look like or what it would be.
yeah,
It would be a chip embedded under your skin, near your ear.
yeah,
And if I wanted to talk to Chris, I say, phone, get me Chris on the phone. And it'll say, which of the 30 Chris's you want? I say, the one we did a podcast with a lot. And the next thing you know, I'd be talking to. That would be pretty optimal phone.
mhm,
If you want to go a little further, we could do a little science fiction and say, I ought to be able to think,
mhm,
uh, Chris, and be able to communicate with you. But that's not scientific.
mhm,
So, and similarly, there are ways to get a visual experience that might be a 60-inch screen
Hmm.
with your personal device. Well, we haven't figured that out yet, but you know that Google Glasses were an effort at that.
Right.
So my view of the future of the cell phone, which I talk about in a later chapter of Cutting the Cord,
Hmm.
is that the phone will be adapted to the individual, that it will contain some artificial intelligence that
Right.
will examine your behavior on a continuing basis, that will find an app. You know how ridiculous the concept of having 2 million apps. All you got to do is find the right one for you, right?
Yeah. Yeah.
This artificial intelligence will either find an app or it will create one that
Hmm.
is designed for you, that serves your purpose.
Hmm.
And so everybody's phone will be different from everybody else's phone, and it will solve big problems, not just social media and finding out what's for dinner when you're on the way home, but healthcare. It was going to be a fundamental purpose of the cell phone.
Right.
The digital divide will provide cell phone-like devices to every student
Hmm.
so that they can access the internet, access learning tools, and people will optimally collaborate. That is the vision of the future cell phone.
Now, when you and I so when you developed the first cell phone, is there anything about what you designed into it that you wish you could have changed at the time, done a little bit differently, considering the trajectory, it sent everything? Is there anything you'd go back and
You
change?
know, it's miraculous that we achieved what we did.
Mhm.
If we hadn't had, I want you to just imagine this: that Motorola was not a small company; it was $1 billion company at the time.
Mhm.
The Bell system had revenues of 22 billion. Uh, they we were trying to influence the FCC. They had two lobbyists assigned to each commissioner,
Mm.
a total of 200 people in Washington, do nothing but lobbying the FCC or the various other governmental entities, the Congress people. So how could a little company like that achieve that? And the reason was that the management knew that we were right,
Mhm.
and they bet the company on it.
Mm.
You know, talk about being fortunate to come into that situation.
Yeah.
So I tell people I'm the luckiest person in the world, and I believe that.
So what about and we just have, I guess we have a few more minutes. I just have a few more questions. What about the current, you mentioned allocation of the spectrum, but how about the current infrastructure? What are your comments about what it's like today?
When you say car infrastructure,
Oh, cell phone infrastructure.
oh well, there are a couple of anomalies that have occurred today that are weird
Hmm.
that have to get fixed. If you've noticed, all the cell sites are outside. Do you notice that?
Yeah.
Where do you make your phone calls? Inside buildings.
Yeah.
So what we have done is put the cell sites in the hardest possible place to reach the people. So in the future, we're going to find that the infrastructure is going to be distributed a lot more rationally.
Hmm.
That that a lot of the cell sites are going to be in buildings,
Hmm.
and the cell sites in the buildings will not interfere with the cell sites on the outside. If you
Hmm.
think about that alone, will increase the capacity of the radio spectrum.
Hmm.
So, what we will find that almost all of the antennas on the infrastructure are going to be multiple antennas, what they call MIMO.
Hmm.
Uh, the way MIMO is used today is mostly for millimeter waves. I think that millimeter waves are a very interesting technology
Hmm.
to be used in the middle of the city for highly dense places. But we're going to find that smart antennas are going to be used at every frequency, and that alone is going to multiply capacity of spectrum by many, many times.
Is that what 5G uses, or?
Yeah, 5G is really it has been overhyped
Mhm,
in the sense that it really is a progression from 1G, 2G, 3G, and so forth.
mhm,
The things that 5G offer are some improvements in the effectiveness of communicating one place to another. The biggest thing that 5G does is 5G allows for uh, assigning segments of spectrum to be used for specific purposes like running factories. Ostensibly, it's going to be used for automated vehicles and things of that nature.
mhm,
So it's what people refer to as the Internet of Things.
mhm. Right.
I think that's a very desirable long-term objective, but I also suggest that we haven't finished the Internet of People yet. And
Yeah.
so what I would like to see is a little better balance between uh, the the objectives of 5G and introducing millimeter waves, high speed just for the sake of high speed alone. Latency, I don't know when the last time you had a problem with latency is, Chris, but latency is not a people problem, it's a machine
Mhm,
problem. The future infrastructure to address your question is going to be focused on for people, it's focused on coverage. What
mhm,
you want as an individual is you want to be able to talk anywhere. A big percentage of our country is not covered by
mhm.
service. There
Right.
are people who don't have service at all.
Mhm,
That's unacceptable. The technology exists, so we have good coverage. And the second one is has to be more affordable.
mhm.
So cellular services cost too much, and that creates what we call the digital divide, and that too is unacceptable.
So do you think, so considering some of the problems that exist with phones, like the ergonomic things or the human factors, and also, all these things they stuff into phones, do you think the industry is too focused on gimmicks for the public versus, more quality products?
Well, the answer yes, but only in this one narrow area.
Mm,
The fact is, the carriers are doing a good job.
mhm,
They are doing a reasonable job of coverage, not
mm,
as good as I would like,
mhm,
but uh, they're doing a reasonable job. The thing that I object to is well, I guess it's two things.
mhm,
One is that they should be emphasizing more about solving the digital divide.
mhm,
They should be doing more to improve coverage. They have to figure out some way to get low cost broadband access to students.
mhm,
And so there should be more emphasis in that area. And the other thing they're doing is they're hyping the 5G, especially millimeter wave, and telling people they're going to get things that are not going to happen for 10 years or longer. I
mhm.
think that's misinforming the public, and they shouldn't do that.
Do you, and I'm not sure how much you might have thought about this issue, but how do you get more students interested in engineering and technology and working on this sort of stuff? How do you get more, because they talk about the US has a problem with that, getting enough students into science.
Well, I have a belief that our whole educational system is messed up,
Mhm,
and it's not something that I evolved myself. But the whole concept of a lecturer standing up in front of a bunch of students and talking to them for an hour on a very narrow subject is not the best way to teach people. The
mhm,
way people learn is by doing things, by
mhm,
solving problems, and we have all kinds of tools for teaching people in that way.
mhm,
The ideal tool of that nature is a game. I don't know if you play the digital games,
mhm.
but these games are interesting. They're challenging.
Yeah.
They're adaptive,
Mhm,
right? If you can't solve a problem, they will give you a different route to solve it.
Mhm.
Well, just imagine if you could create an educational system based upon game playing
Mhm.
that and using that to teach people. So I think that improving the teaching process will persuade people that learning is one of the great things of life, maybe the most important thing of life. And if people start learning, we're going to have lots of engineers available.
Yeah.
Uh, one of the objections I have, I'm sure that I'm diverging from your questions, is that we treat everything in silos.
Mhm.
Silos as an example in elementary education. We talk about history, geography, arithmetic. The world doesn't live in silos. The
Mhm.
world doesn't have chemical engineering, electrical engineering, aeronautical engineering. The world has problems that have to be solved.
Mhm.
And so I think our whole way of thinking about how we teach and how we approach the problems is changing. We have to think more in terms of design as being the fundamental process, and these other technical issues as being sub processes that are applied depending on what the design demands are.
Yeah. Just talking to you about this, both the combination of the cell phone and the internet, I think have allowed society to, both communicate information basically in a faster and more efficient and interesting way. And I think both have contributed together to really raise the sort of knowledge and intelligence of society. So I just wanted to make that comment, and thank you for that that
You,
contribution.
you said it a lot more tersely than I did, but you're exactly right.
Yeah, I mean it's amazing, you know, someone might say, well, eventually they'd come up with a cell phone, but the fact is you and your team did it at that time and kickstarted, set us on the path to where we are, as far as science and technology. So that's just
I
my
think
comment.
I think you expressed it right. We know that ultimately it would have happened either way, but I think we jump started it.
Hmm. Yeah. So so do you where can people find you on the web? Do you have a website or social media that people can follow your thoughts?
Yeah, well, I'm at Marty Mobile on Twitter.
Hmm.
I do have a martycooper.com. Uh, Unfortunately, at the moment, it only leads you to, well, I shouldn't say that. It will lead you to how to buy my book, Cutting
Okay.
the Cord, if I could do it by commercial.
Yeah.
But it also leads you to the site of my wife and I have a site called Dyna LLC that is our incubator.
Hmm.
And there is a list of papers on that site that I've written that people might find interesting. And there's also a segment on the pipe on the site for students who are doing projects
Hmm.
where they want to talk about the invention of the cell phone, where we give them resources. So martycooper.com or dynallc.com are
Okay.
where you find me.
And I'll spell that. So Marty Cooper is MartyCooper.com.
You bet.
And Dyna LLC is what? DYNA
Right.
LLC.com.
Correct.
Okay. All right, cool. And I was gonna ask, what's your next writing project? And maybe it'll be this book on management and developing innovation. Perhaps you might do that.
Well, it's on the list, Chris. My list keeps growing. I would love to talk about self-optimization,
Mhm.
and but somebody asked me just recently whether I am a procrastinator or an organized person, and I told them I'm 100% procrastinator. I have never understood the concept of discipline. I ran huge businesses for Motorola, and I was the world's worst executive. I mean, why they tolerated me, I'll never understand. So I can't tell you what the next project is, but I'm gonna keep going as long as I can.
Appreciate it.
Anyway, great pleasure to be with you, Chris. I hope this is useful to you, and I hope a lot of people attend your.
Yeah. And I want to thank you again for speaking with me and also for developing and creating the first cell phone for the world. That's pretty awesome. I appreciate it.
My pleasure for both of them.
Thank you for watching this video version of Technology and Space. If you like this episode, please subscribe for more. If you want daily book suggestions for new science, technology, space history, and space, please check out my YouTube channel, Spacewalks Money Talks, and my website, technologyandspace.com. If you're looking for new military and general history information and books, check out warscholar.org, my YouTube channel, Warscholar 1945, and my podcast, Military History Inside Out. If you're looking for new fiction and nonfiction books on sci-fi, fantasy, horror, gaming, and more, check out chrisalvarez.com and my podcast, Full Contact Nerd Interviews. Thank you for listening.